Logarithms. Yesterday we were solving equations, exponential, and what logarithms do is they allow us to solve an equation where our exponent is a variable. Okay? Meaning, we have been able to solve 2x is equal to 10, but we have never been able to solve something that looks like 2 to the x power is equal to 10. Is everybody with me? So logarithms allow us to do that. I know you can't really see that, but. All right, so what is a logarithm? A logarithm is read as log base b of a is equal to x. Now, remember yesterday we were talking about the base number? Okay, so this is read as log base b of a is equal to x. And in logarithm or exponential form, that is read as b to the x power is equal to a. So b to the x power is equal to a. All right, this is really, well, I'm going to show you this. I have a way of showing you this. It's going to seem really stupid today, but as we keep doing this, I promise you, you're going to use it. Okay? Even people in AP Calculus are still doing it.
Isn't there just a button on the calculator for this?
No, sir.
What's the log button for?
I'm going to get there, okay? But it's not going to give you what you need it to do. All right? So, right here, converting log to exponential form. What we are doing here is we are going to make log form look like exponential form. We use this thing called Loggy Froggy. I didn't invent it. I'm just showing you what it is, okay? Now, remember I can't draw. If I have log base 3 of 9 is equal to 2, a way of remembering how to do this, and it's going to help when we start solving equations, if I have this, I'm going to rewrite it right here. Log base 3 of 9 is equal to 2. Y'all know those ugly, big, nasty, I hate frogs anyway, those nasty, flat, bullfrog looking things? Y'all know what I'm talking about? All right, that's what this picture is supposed to look like, but mine doesn't, okay? If you start here, it is 3 squared equals 9. That's supposed to look like a frog. Mine doesn't. I'm showing you that because I promise you, you're going to use it when we start solving equations. So when I write this, log base 3 of 9 equals 2 into exponential form, it is 3, that's where I started, squared equals 9. Is that a true statement?
Yes.
All right, so this is going from log form to exponential form. That's my answer. 3 squared equals 9. So we are just rewriting these equations.
Is 6 cubed equals 216?
Very good.
Oh my goodness.
So number 2 is 6 cubed is equal to 216. All right, number 3, what would that one be?
7 equals 1.
7 to the 0 power is equal to 1. Isn't anything to the 0 power equal to 1? All right, can you check all of these? Because they have to be a true statement, guys. You can't write new math rules. All right, for number 4.
2 cubed equals 260.
Number 4.
2 cubed equals 16.
2 to the 4th is equal to 16.
Can you have a negative exponent?
Yes, sir.
I like that.
All right, number 5. I have 4 to the negative 2 is equal to 1 over 16. And number 6, I have 9 to the 3 over 2 power is equal to 27. Questions on that? Easy enough? All right, so now we're going to go backwards. We have 14 squared is equal to 196. And we're going from exponential form to log form.
Oh, we going backwards. Oh, Lord.
All right, so this one is written as log base 14. Guys, that is a subscript, so it has to be written down. Log base 14 of 196 is equal to 2. Logarithms deal with exponents. It is always equal to the exponent. All right? Logarithms allow us to solve exponential equations. And so it is always equal to the exponent. All right, for number 8, I have log base 3 of 81 is equal to 4. All right, number 9, I have log base 12 of 12 is equal to 1. Now, could I check these using Loggy Froggy? And guys, you'll hear me saying Loggy Froggy all the time. 14 squared equals 196. 3 to the 4th equals 81. All right. Number 10, I have log base 36 of 6 is equal to 1/2. Number 11, I have log base 2 of 1 over 8 is equal to -3. And the last one, log base 8 of 16 is equal to 4 over 3. All right, questions on either of that? Everybody good there? All right, a common log is when we have base 10. So it says a logarithm with base 10 is called a common log and can be written without the base. So if you ever see something as just log of x or log of whatever, that means it is base 10. That's what your calculator does, is log base 10. So if you see something, so if you don't write the subscript or what the base is right here, you have written a completely different number because it would be 10 to whatever power. Now, looking at number 13, we're going to use what we know to evaluate these logs. I have log base 7 of 49. Now, I'm going to pretend this is equal to x. What this is asking me is, what do I raise 7 to equal 49? All right, so this answer is 2.
You have to show me stuff like this.
All right, number 14. What do I raise 3 to get 27? 3. All right, number 15. What is my base? 10. What do I raise 10 to get 100? 2. right. Number 16. What do you raise 12 to get 1? You raise it to the 0 power. Does anything to the 0 power is equal to 1? All right. Number 17. What do I raise 2 to get 64?
6.
Can y'all not see? Can you not see with the light off? No. All right. What do I raise 3 to get 243? All right. What do I raise 9 to get 1 over 81? -2. And what do I raise 64 to get 4?
Three.
Is it a fraction?
Yep.
You want 8?
No.
Is 1/4?
1/3.
1/3.
No.
Could've swore it was 3.
64 to the 3rd power is like something big.
Oh, I mean, I just did 4 cubes.
Well, we're not doing 4. We're trying to take 64.
I got 130.
I just said that.
We're trying to take 64 and get 4.
This is 1/3.
If you raise 64 to the 1/3 power, you get 4.
Yes, you do.
Is the cube root of 64 4?
Yeah.
Okay. What this is telling me is that 4 cubed is 64. But if I start with 64, I've got to get 4. Does everybody understand?
I'm not good at finding them numbers.
Well, you gonna be. All right. Now, this is in a perfect world, right? What happens if I ask you, what do I raise? These aren't even really bad. Log base 16 to 6 of 64. What do you raise 16 to get 64? No. Square root of 16 is 4.
So 4.
All right, let me show you what to do. This is the change of base formula. And it says some logarithms are not as easy to evaluate as those above and require the change of base formula. If I have log base b of a, I can do log of a divided by log of b.
Oh, okay.
Now, let me explain something to you. Log of a divided by the log of b is not the log of a over b. Does everybody understand that?
Yeah.
Your log button on your calculator is base 10. That is why we have common logs, and that's why we have the change of base formula. So when I put this in the calculator, the log button is right beside the 7. And I'm going to say log of 64, close your parentheses. I would suggest everybody doing this.
I can't see it.
Log of 64, close your parentheses, divided by the log of 16.
So you put the 64 first and 1 up.
Yes. It's log of A over log of B.
I got 1.5.
1.5 is your answer.
Okay, that's 3 over 2.
Or 3 over 2, whichever way you want to write it. That means that 16 raised to the 3 over 2 power is equal to 64. Now, when we do logarithms, is everybody listening? This is like one of my pet peeves. We have 4 decimal places rounded correctly because we're in math 3 and we can round. Does everybody understand that? Yep. How many decimal places?
4.
4. All right, so for number 22, I have log of 32 divided by the log of 8. So log of 32 close divided by log of 8.
I got 5 over 3.
So math, enter, and you get 5 over 3.
All right.
5 over 3 3.
All right, number 23. I have log of 54 divided by the log of 2.
5.7.
And if you put 5.7, I'm going to say minus some points. Why?
Because I did not round. I was only saying 5.7 because it's just 5.7.
No, it's not. How many decimal places?
2.
Guys, I just said it.
It's 5.
I said it like 3 times. Did I just say 4 decimal places like 3 or 4 times?
Yeah, that is. So it's 5.7.
Whew.
5.4.
5.7549. 4 decimal places rounded correctly. Does everybody understand that?
Yes, ma'am.
Why is it the 4th decimal place?
Well, because I'm not asking you to write all of them.
All right.
And because if you just do 5.7, 2 raised to the 5.7 is not 54, it's 51.98.
So
That's
if
not
you
the
put
right number.
2 to the 5.7,
It's closer.
549 is closer.
2 raised to the 5.7549 is 54.0000.
You know what you're doing then. You got it.
Does everybody see that? If you write 5.7, is that equal to 54? You see you get 51.98? You see if you put it raised to the 5.7549, you get that it's equal to 54?
Yeah.
It's kind of like on your test. If you write 51 and the answer's 54, what's going to happen?
Wrong.
For the next one, since it's base 10, do we have to put the 10 in the parentheses and calculate it?
Well, you're going to do log of 294 close divided by log of 10. So 2.4683.
Yeah.
Let's put these in your calculator. All right, number 25. What did you get?
I got 3.5437.
All right, and number 26.
-2.
All right, so I want you to look at something. I was telling you to put these in your calculator because I'm going to go right here to number 23. You put that in as log of 54 close divided by the log of 2, and you get this. If you do log of 54 divided by 2, you get that. Are they the same?
No.
No. If you do log of 54 divided by the log of 2, is that the same? That is why you have to close this parentheses right here at the 54. That is why I wanted you practicing doing this. Does everybody follow me? The calculator is only as smart as the person working it. Y'all make mistakes by not practicing it and then swearing that's the answer. All right, any questions on that? That is what logarithms are. Everybody good? All right. Yours